Hi, my name's Jess. This is my LabVIEW project for Engineering 267, designing a function generator, spectrum analyzer, and oscilloscope for in LabVIEW. This is my function generator here, and if we run this, we get a sine wave, and we can change the waveforms using this button. 0 corresponds to DC, which is also our default. 1 is a sine, 2 is a square wave, 3 is a triangular wave, 4 is a sawtooth, and 5 is our DC. And any other values besides 1 through 4 will create a DC wave. For the purposes of showing the functionality of this, we'll just use a sine wave. This knob right here corresponds with adding noise, so you can add noise here. When you do this, it shows some measurable values here, the maximum, minimum, average, range, and with the noise, they're jumping around here, so we can go up here and push stop. And that freezes these values here, so we can get a better reading. But to show you how we can use the functionality of this, we'll change the amplitude, we'll say here to 50. So that raises that, and how about we change our frequency to 150. All right, and just to show that the offset DC value works too, let's show you we can move it down a little bit by minusing, or move it up a little. Oh, maybe, there we go. Yeah. But for functionality purposes, we'll keep it at 0. No need to add any of that extra in here. So with a frequency of 150 and an amplitude of 50, our spectrum analysis, we should expect to see a spike here at 150 right here with an amplitude of about 50, and the noise is causing it to jump up and down, so go up here and make sure this is at 0. There we go, turn that off. All right, and if we want to better see this, we can use this little knob right here to adjust the resolution here of the x-axis. It's pretty touchy right there. So this corresponds pretty well with what we're expecting to see. And if this were a square wave, we'll go up and change that real quick. We should have multiple peaks. So here's our square wave. We go look at our spectrum analysis, and there we have our 2 peaks right there. And then if we want to see this on the oscilloscope, it shows that our maximum here is 63 with a frequency of 150 hertz. I'm not sure why that is 63 when it should be 50. Maybe because of the type of waveform we have. All right, so the cursors are functional. Here's a cursor that corresponds with X, and then you can either use these buttons as well to adjust the cursor. So this moves it up and down. Over here, this will move it left to right. If you adjust these to your preference, say right about here, the values it gives you. Oh, nope, it's a little touchy. So the difference right here, that is your peak-to-peak values. These differences, if you want to place the cursor points at peaks, you can also do that as well to find time scales, and you can adjust the volts per division using this knob right here, or the seconds per division using this knob over here. And use the values you get there to gather measurements. And in my block diagram, I have it programmed to where these machines can read a maximum number of 20,000 hertz. So if we go above 20,000, it should give us an error. So at 20,000, we've got a straight line there pretty much, and then one above, and we get that error. That is my LabVIEW project. Thank you very much.